Okay, welcome back everyone. Today we're going to have a workshop on Intro to Functions. So on this topic there are 4 objectives and we are going to go over them one by one. For objective number 1, it is I can plot points and identify attributes of the coordinate plane. So the first question is, what's the ordered pair of point A below and what quadrant it can be found, or can it be found? So strategy on this is to just, use your pin and then from the point attach it to the x first because it's a set of ordered pairs, and your x is -8 and your y is at -7. So this means that your point A has coordinates of -8, -7, which is your x and your y. So now what's going to happen is we're going to identify the quadrant, and the quadrants are, this is quadrant 1, quadrant 2, represented by Roman numerals, quadrant 3, okay, and quadrant 4, which is IV, and it's like a letter C, like this, it goes this way. So again, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So example number 2, what's the ordered pair for H and what quadrant can it be found? It's the same strategy that we're going to use on this one. So again, you're from your point connected to your X and then connected to your Y. Now after connecting it to your X and your Y, you see that the coordinates of your point are -6 and 3. -6 for X, 3 for Y. For the quadrant, you know that it's at quadrant 2 because once again, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So H is at quadrant 2. Next question, which of the following points can be found in quadrant 4? Select all that apply, and you know that it goes on like this. This is 1, this is 2, this is 3, and this is 4. And these are the points that are on quadrant 4. Question number 4. George was trying to plot the point 37 in the coordinate plane below. Which of the following correctly shows the location of the point George was trying to plot? So let's go ahead and examine all these. Starting with point A, I'm going to connect it to the X, which is at 3. And then I'm going to go ahead and connect this to the Y, which shows 7. So I guess we have found the point, and point A is the one that George is trying to plot. Just to have a practice, I want us to have fun on this one and get the coordinates of all the points. So let's look at B. I'm going to connect it to the X, and that is giving me a 7. I'm going to connect it to the Y, and that's giving me a 3. Okay. And now go to C, connect it to the X, and for that we have 7 again. And for the Y, it's at the bottom, so it is -3. Okay. And for D, connect it to the X, and that is a -7. And then connect that to the Y, and it is giving us a 3. So there you go. All the coordinates of all the points have been generated, and our answer on this one is A, and A is on quadrant number 1. Objective number 2, I can distinguish between relations that are functions and those that are not. Okay, so what I want you to do whenever you have a mapping like this one is I want you to generate all the ordered pairs, and from there you would know that it is a function if X does not repeat. So X must be paired up with a Y value just one time. So if it is paired up more than one time, which means that you see X more than once, then that is not a function. Okay, so this is what I'm talking about. So 2, 4 is there, 3, 8, 4, 8, and then 5, 5. If you notice, the X here is not repeating, so therefore that is a function. But I want us to all generate all the ordered pairs on this one so we can examine. For letter B, I have 1, 2, and then 1, 3, 4, 6, 5, 6, 7, 8. Notice that here 1 is repeating, so that tells us that this is not a function, and whenever it's not a function, guys, There's a special name for it also. It is a relation. So, but this is also a relation. So what is a relation? A relation is whenever you have the x and the y values in an ordered pair. So every time you see an ordered pair, that is a relation. However, it becomes a function if x does not repeat. On here, x is repeating, so once again, b is not a function. I also want to focus your attention on the 6 here under the y that's repeating. That's not even our concern. Whether y is repeating or not repeating, that is not our concern. Just look at the x. If x is repeating, then that is not a function. Okay, so we did the same thing on letter C. So 4, 7, 5, 2, 5, 9, 8, 5. As you can see, 5 repeats. So therefore, C is not a function. So do the same thing with letter D. You'd see that X is repeating. So letter D is not a function. The answer on this one is letter A. So now, question number 2 in objective 2. The same thing, guys. Look for when X repeats. That is not a function, and that's what you're looking for. So let us check on this. The answer here is T, because you can see that on X, 3 has repeated. In all these, X has not repeated except for T. Question 3, the same thing. Which ordered pairs represent a function? Let's examine. A is the answer because X has not repeated, but let's examine all these. This is not a function because of the 9. It's repeating. Letter C, it's not a function because of the 3. Letter D, it's not a function because of the -1. The answer here is A. What happens if you have a graph is you're going to do the vertical line test. Your vertical line must touch the graph only once for it to be a function. So in here, when I do the vertical line test anywhere on the graph, it is a function, guys. This is also a function. This, if you put it here, you're going to say, okay, it's not touching the graph many times. It's just touching the graph once. But look at this part right here. If I put my vertical line test there, then that's not a function because it is intersecting the graph 3 times. 1, 2, and 3. This is also not a function. So this is a function. Okay, this is a function. This is not a function. This is not a function. This is a function, and this is not because of the vertical line test here. Yeah, you can try to do the vertical line test and it will show you touching the graph only once. Right, let's keep on going. Objective 3. I can evaluate functions given one or more elements in their domain. So the domain here is the -3, and this is your function. So what we're going to do here is we're going to use Desmos. Alright, after plugging it in on Desmos, it looks like this now. Yes, and all you will do now is to type in the f of -3 here, and it would show you your y value, which is what you're looking for. Okay, example number 2. What is the value of f of 5? So what you're going to do is the 5 inside your parentheses is actually your x value. So you go to x that has 5, make it touch your graph, because that's what you're looking for, and then connect that point on the y, because it's the y we're looking for. So here, the answer for f of 5 in this graph is that it's equal to 2. Question number 3, f of x equals 7. What is f of 8? Well, first of all, you're already saying that your function, which is y, is 7. So whatever happens to your x, your y is still 7. So the answer here is 7. Because no matter what x is, it can be 0, it can be -1. In this case, it's 8. Your f of x, which is the function of x, is still at 7. So let's examine Desmos on this one. So I plugged in f of x equals 7 here. Notice that this line has all the values for y as 7. So no matter what x is, in this case, your 8 is somewhere here. There you go. So whenever your x is 8, in this case 8, the y value, which is what you're looking for, still is 7. So in this case, f of 1, so you go to when x is at 1, which is right here, and you go attach it to the graph, right there, and attach it to the y, which is what you're looking for, and the answer here is -1. Moving on, objective 4, which is our last objective, I can calculate slope as a rate of change. A teenager weighed 145 pounds in 1986 and weighs 190 pounds as an adult in 1995. What's the rate of change? Notice that I have already labeled it. 145 pounds is your Y1, 1986 is your X1. Now, how was I able to distinguish between the two, where X is and where Y is? Time is always an independent variable. So time is always your X value. Independent is X, okay? So if 1986 is X, then definitely this is Y. So X1 and this is your Y1. And once again, 1995 is your X2. So therefore, 190 is your Y2. Rate of change means slope, and you're going to use the slope formula. Okay, so the slope formula is Y2 minus Y1 over X2 minus X1, or we can call it rise over run as well, or delta Y over delta X, delta meaning change. So change in Y over change in X. So after substituting, so 190 minus 145 over 1995 minus 1986, we're going to use Desmos. Notice that when I use my Desmos over here, I have placed the numerator all in parentheses and the denominator all in parentheses. And the answer is Y equals 5. And Y equals 5 means 5 pounds over 1 year, which is your rate of change. Example number 2, a climber is on a hike. After 2 hours, he's at an altitude of 400 feet. After 6 hours, he's in an altitude of 700 feet. What is the average rate of change? Again, hours or time is independent, which means that this is your X value. Dependent is your Y value. So we're going to label them. Now, after I label them, I write the formula back for the slope, and then I'm going to substitute. So my Y2 is 700 feet, and Y1 is 400, so 700 minus 400, all over X2 is 6 hours, that is minus 2 hours, and then I'm going to use Desmos. Okay, making sure that I plug it in correctly, I'm using the parentheses. My Y is 75. What that means is 75 feet per hour is my rate of change or my slope. So when you're given a table, the same thing, you're going to calculate the rate of change by picking, in this case we have 4 points given, 1, 2, 3, 4. This is your X and this is your Y. Just pick any 2 points and you can use the formula. So these are the 2 points I chose. And this is the X column and this is the Y column. And I'm choosing this to be my Y2. So I'm plugging it in, 20,000 minus 16,500. Then here, when you start with your X, you also have to start where you started from the beginning. So if it's in the 20,000, you'll have to write down first your 1980 and then minus 1985, and then you're going to use Desmos. So I plugged it in on Desmos, and the only reminder I have for y'all is to make sure that you don't put the comma. So 20,000 will just be written this way, and 16,500 will just be written this way. And the answer is negative 700. And negative 700, that means that's your slope, negative 700 people per year. And the next example is, what if you're given a graph? What you're going to do is you're going to identify any 2 points and do the same thing, use the slope formula. So after identifying the points, we have for this one 0, 10, and this one is 37. You're going to label X1, Y1, X2, Y2. By the way, they're interchangeable. You can also label this as your X2, Y2, and this can be your X1, Y1. The slope will be the same. Now, depending on our label, the formula now, after substituting, I have 7 minus 10, and then 30 minus 0, and that would be negative 3 over 30. Using the technology and Desmos on this one, I had plugged it in, it gave me a decimal, but look here on the side, it has a function to where when you click it, it's going to be a simplified version of your fraction. And that is negative 1 out of 10 inches per minute. Last and final example, you're going to again identify 2 main points. So these are the 2 points I have identified. I placed their coordinates. I labeled them X1, Y1, X2, Y2. I used the formula. I plugged it in on Desmos, and it gave me 15. So 15 means $15 per day. So that is it, guys, for our workshop or on intro to functions. So I hope that you have learned a lot, and good luck.